Estimate the integral from 0 to 1 of sine x squared dx with error less than 0.0001. So from our list of series, sine squared is the sum from n equals 0 to infinity of negative 1 to the n, x to the 2n plus 1, so we're going to have x squared to the 2n plus 1 divided by 2n plus 1 factorial dx. So we can integrate term by term. The sum from n equals 0 to infinity, and this is x to the 4n plus 2, so that's going to be, when we integrate negative 1 to the n, x to the 4n plus 3 divided by 4n plus 3 along with 2n plus 1 factorial, and evaluate it between 0 and 1. So this is equal to the sum from n equals 0 to infinity. Evaluated at 1 just gives us the alternating series negative 1 to the n over 4n plus 3 times 2n plus 1 factorial minus this sum evaluated at 0. Fortunately, when we evaluate this at 0, we get 0. So our estimate for this integral is an alternating series. This is pretty nice because back a few sections ago we found that the remainder, an absolute value, otherwise known as the error, is less than or equal to the next term for alternating series. So what we're going to do then is try to solve by trial and error this equation. 1 over, and we're looking at the n plus first term here, so that's going to be 4 times, remember, n plus 1, so that's going to be 4n plus 4 plus 3, or 4n plus 7, very carefully, along with 2n plus 1 factorial, which is going to be 2n plus 1 factorial, or 2n plus 2 plus 1 factorial, or 2n plus 3 factorial. And we want to set this to be less than 1/10,000th. And the only thing to do here is probably just use trial and error. So if n equals 1, we're going to need a calculator here, I know that. We're going to get 1 over 11 multiplied by 5 factorial. And if I break out my trusted calculator, that's going to give me 7.6 approximately times 10 to the minus 4. Moving over 1, 2, 3, 4 places means we would have an error less than 7/10,000. So that's not quite good enough. We'll need to do a second term. And since the term here has a factorial in it, I'm sure that the next is term, if we do just n equal 2, that's going to be enough to get our error less than 0.001 because of the presence of this factorial here. So let's evaluate n equals 2 and see what we get. 1 over 4 times 2 is 8 plus 7, 15. Multiplied by 2 times 2 is 4 plus 3 is 7 factorial. And let's see what we get approximately there. 1 divided by 15 times 7 times 6 times 5 times 4 times 3 times 2, and that gives me 1.3 times 10 to the negative 5, and yep, that'll do it. 1, 2, 3, 4, 5. So that gives us an error of less than 13 millionths. So that means if we want to estimate with an error less than 0.0001, we're going to need not one term, that won't do it, but n equals 2 terms, and then the error will be less than 13 millionths. So the estimate then for 0 to 1 of sine x squared dx is equal to the sum of the first two terms here. Let's find that. So if we plug in 0, that's going to be 1 over 3, just 1 over 3. Double check that's negative 1 to the 0 is 1. 4 times 0 plus 3, 3. 2 times 0, 0 plus 1, 1 factorial, 1, so that's 1/3. Next term is going to be negative 1 over, and we'll plug in 1 here, so that's 7, multiplied by 1 here, 3 factorial is 6, and even I can do this without a calculator. So this is 42, so if we multiply both of these by 14, we get 14 minus 1 over 42, which is 13 over 42, or here's where I draw the line. We'll go into the calculator on this. I'm not doing long division out at the end of the semester. It's 0.3095. And that approximation is accurate with an error of less than 0.0001.